In this video, we're going to talk about simplifying radical expressions. So recall, the nth root of a to the n, if n is an even integer, is the absolute value of a, and if n is an odd integer, is just a. We're going to use that idea to help simplify radical expressions. Well, let's take a look at the first couple of examples. We know from previous examples that the cube root of 27x cubed I can rewrite as 3 cubed x cubed. And we know the answer to this is 3x. We can do something similar with this fourth root example. That's the fourth root of, this is 2 to the fourth, and this is y squared taken to the fourth. And when I take the fourth root of each part, I get 2y squared. Now, this is great, but not all radicals are going to be perfect roots. So the idea for us then is we want to simplify radical expressions by pulling out perfect roots and simplifying as much as possible. All right, so let's simplify each radical expression. So in order for us to do that, I will create a factor tree to write out all of the factors, prime factors, of a particular number. So for 72, one way I can break this down is 8 times 9. 9 breaks down as 3 times 3. They're both prime. 8 is 4 times 2. And then 4 I can break down as 2 times 2. So the square root of 72 is the same thing as the square root of 2 times 2 times 2 times 3 times 3. Now, because the index is 2, if I get two factors that are the same, I can take one of them out to the outside. So here I can take a 2 times 3 to the outside. I didn't do anything with this 2 here, so that goes back inside the radical. And then I take 2 times 3, and that's 6, times the square root of 2. So the square root of 72 is exactly the same thing as 6 times the square root of 2, pulling out all its perfect roots. Okay, let's do the next example then. So again, I want to do a prime factorization of 54 using a factor tree. Well, that is 9 times 6. 6 breaks down as 2 times 3. And 9 breaks down as 3 times 3. So 10 times the cube root of 54 is the same thing as 10 times the cube root of 2 times 3 times 3 times 3. Now, because the index is 3, I need 3 of the same factors to take 1 out. The only thing here is a 3. Since I've already got a 10 on the outside, I take the 10 and multiply by the 3 I'm going to put on the outside. The 2 still stays under the radical. And then take 10 times 3, and that's 30. Okay, so the next few examples, the only thing different I'm going to add is variables under the radical. All right, so let's start with 125. So 125, that breaks down as 25 times 5, and 25 breaks down as 5 times 5. Now, let's rewrite. Now, the variables should actually be easier. I can break down x squared as x times x, and I can break down y to the 5th as y being multiplied by itself 5 times. Now, the index is 2, so I need 2 of the factors to be the same in order to pull 1 out. So the negative 3 is already on the outside, so that's times 5. Remember, the square root of x squared, that's the absolute value of x, times y, and I have a 5 times y that still stays under the radical. Simplify, that's negative 15 times the absolute value of x times y squared times the square root of 5y. And that is pulling out all the perfect roots. Okay, let's take a look at the next example then. So, the prime factorization of 128 is this. Okay, so now we can write 5 times a cube root of 128 x to the 6th y to the 10th can be rewritten as this. Now, because the index is 3, I need 3 of the same factors. So I can do this. So this is the same as 5 times 2 times 2 times x times y times y times y times a cube root of 2y. Simplify. And we're done here. Okay, one other example then. So again, let's do the prime factorization of 32 now. Okay, so I can rewrite this as this. Since the index is 4, I need to circle 4 of the same. So this is 2 times x times y times the 4th root of 2x, y to the 3rd. Simplify, that's 4xy times the 4th root of 2x, y to the 3rd.